Okay, so I'm going to quickly run through C2 June 2014 MEI paper. I won't go all of it, I'll just do each question until I think it's obvious how to finish off. So starting on question 1, we're asked to integrate 7x to the power of 5 halves dx. So normal rules for integrating: 7 x to the 5 halves, so if I add 1 to that, that adds 2 more halves on, so we get to the 7 halves, divide by 7 and times by 2. Okay, you'll then see that that 7 and that 7 will cancel, so we get 2x to the 7 halves plus c. There is actually one mark for writing the plus c, so do remember to put that there. Question 2. Okay, it says this symbol, which means add up from r equals 1 to 5 all the terms which are given by using this formula and plugging the 1 in, the 2 in, the 3 in, the 4 in, the 5 in. So when we put 1 into there, we get 21 over 1 plus 2, which is 3, plus put 2 into there, so we're going to go all the way from 1 up to 5, put 2 in there, 21 over 2 plus 2 is 4, put 3 in there, 21 over 3 plus 2 is 5, 21 over, so I've put 1 in, 2 in, 3 in, putting 4 in, I've got 6 on the bottom, and then I put 5 plus 2 is 7. Use your calculator, add it up. Okay, so you can't see all of that later. Okay, number 3. Now I always draw a little diagram with questions like this. It says the points P and Q lie on the curve y equals f of x. Work out really whether the curve goes this way or this way. And you can do that by looking at the y values. So it's only a very rough sketch, but basically I've got a curve that's going to come down here. So my point P is there, my point Q is there. So the coordinates for P are 2, I'll just move it up, sorry, and 3.6, and the point there has a x coordinate of 2.2 and a y coordinate of 2.4. Now if we read the question, it says use P and Q to estimate the gradient of the curve at the point where x equals 2. So the gradient of the curve would actually be this gradient of this tangent, and you can see that the gradient of this chord, so from P to Q, isn't that far off. So that's what they're wanting us to do, is to work out the gradient of this bit from here to here. So if we draw a little right angle triangle in, we can then just use the gradient is the change in the y, so 3.6 take 2.4 is 1.2, divided by the change in the x, which is 0.2, and because I can see the gradients this way, it's negative, and then you get your answer. Okay, so moving on, question 4. The point R, 6 minus 3, is on the curve y equals f of x. Part 1 is asking us to find the coordinates of the image of R when the curve is transformed by y equals a half f of x. So a half f of x, remember, if it's outside of, it's not inside this bracket, it's to do with the y direction, and if it is in the y direction, it does exactly what the number there says. So this is a vertical stretch, scale factor of a half. Okay, so if I have a coordinate, which is down here, 6 minus 3, and I'm going to do a vertical stretch scale factor of a half, then that's going to come up by a half. So the new coordinate will be 6 minus 1.5. Okay, the coordinates, the next part, sorry, part 2, find the coordinates of the image of R when the curve is transformed to y equals 3f of x, beg your pardon, f of 3x. So this time it's inside the bracket, so it's in the horizontal direction, and in a horizontal direction it generally does the opposite. So this is a horizontal stretch, scale factor a third. So if we go back to the diagram, this point here is going to come back in here in this direction, so instead of being out here at 6, it will only be 2 along. So the new answer is 2 minus 3. Okay. Question 5. You've got a triangle that looks roughly a bit like this. You've got A, B, C. You know this angle. You know this side. You know this side. Okay. The question just describes that and says calculate the length of AC. So we're going to use the cosine rule. So in this question, this one here is little b squared equals a squared plus c squared minus 2ac cosine of the angle. And then you can just plug things in. Make sure, because this angle is in degrees, make sure your calculator is in degree mode when you do that question. Okay, next question, number 6. If you are struggling with number 6, it probably means that we haven't yet taught you the radians. So I will just very briefly go through this one. If I just move my piece of paper up. You've got something like this. Okay, and that's 2.1 and it's marked in as radians, and that's 12.4. And the question's asking us to find the area of this shaded bit. Well, the key thing here is to find the area of the sector, and then, if I write that down, subtract the area of the triangle. Now, there is a formula for the area of the sector, which is quite simple. So it's a half r squared theta, when theta's in radians, so you don't need to go back to degrees. And then the area for the triangle is a half AB sine C, but in this case A, B are both radiuses, so it's r squared sine theta. And then you would just plug in these values. This is the radius, this is the angle, and you would plug those in, make sure you're in radians. Okay. Question 7. Second term of a geometric progression is 24, so we would I'd write GP to make sure I know it's a geometric. A2 equals 24. Sum to infinity, so we write that like that, is 150. Write down two equations in A and R, where A is the first term and R is the ratio, and then find possible values of A and R. So we're going to use this bit of information to start with. So the fact that A2 is 24, well, A2 is A times by R to the power of 1. So I've got AR equals 24. That's one of my equations. The second one, use this information. The formula for the sum to infinity is A over 1 minus R. So in this case, A over 1 minus R has to equal 150. Solve those two equations. Probably easiest to make A the subject of both of them, and then you'd have an equation which will help you to find R, and for each value of R you can go back and find a value for A. Question 8. Simplify 1 minus cos squared theta all square rooted over tan theta. Okay, so the two identities we're going to use in this is that sine squared theta plus cos squared theta equals 1. So you can see here that 1 minus cos squared theta, if I take that to the other side, is simply sine squared theta. And then when I put that under the square root, that makes that quite straightforward. And the other thing we're going to use is sine theta over cos theta equals tan theta. So if I plug those things in, here I get sine squared theta, square rooted, over sine theta over cos theta. Now some of you will know exactly what to do, and some of you might not be sure what to do with this bit here. So treat it as a fraction. This here is sine theta, and we're going to divide it by this thing. When you're dividing by fractions, you make that a multiply and you flip this upside down. So we would then have sine theta times by cos theta over sine theta. Sine and sine cancels, the answer is cos theta. Okay. Next question. Question 9. Solve the equation tan 2 theta equals 3, and it's telling me that theta is between 0 to 360. Now, what some people I've marked this, have done, is they've divided by that 2. That's incorrect. Tan 2 theta equals 3. So if I use my calculator, make sure it's in degrees because this is in degrees, and I just do inverse tan. Let me just check I am in degrees. I'm not. Okay, so inverse tan of 3, and I get the answer 71.6 degrees. So 2 theta has to equal 71.6 degrees. So if I now draw my graph of tan, okay, let's just do this as reasonably quickly. With tan, you do need to be quite neat. It's not actually my strength. 90, 180, 270, 360. Now, because theta is between 0 and 360, means that 2 theta can be between 0 and 720. So I need to keep going here. So 360, 450, 540, 630, 720. Draw my asymptotes. Okay, so the graph comes down here, and it comes down here, down here, down here, and then it would come down there, so it's down there. So the first value of 2 theta is going to be 71.6, so that's about there, I would say. So if I draw my line across there, so that's where, this is where tan 2 theta equals 3, there, 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 and there. So this first one is 71.6. This one here is 180 plus 71.6, which is 251.6. This one here is 360 plus 71.6. 360 plus 431.6. And then this last one is 540 plus 71.6, so 540, 610, 611.6. So if I've got that right. So that's what 2 theta is. So now, when I work out what 1 theta is, I'm going to half each of these numbers, and you'll see that they all come back into range of between 0 and 360. Okay, so you would be able to finish that. Question 10. Use logarithms to solve this equation. 3 to the x plus 1 equals 5 to the power of 2x. So things I'm wanting to find are in the air, so I'm going to just bring the powers down. Beg your pardon, take logs of both sides. Log of 3, bring the power down, put it in a bracket because it's all of that. This one doesn't need a bracket. Okay. Now sometimes people get a bit confused about how to solve this. If instead of you thinking of it as solving it, you think of it as rearranging to make x the subject, that basically means expand this bracket, put all the x's on one side and everything else on the other side, and essentially that is the same as solving it. So the first thing I'm going to do is expand this. So x log 3 plus log 3 equals 2x log 5. You can do this in any base, and some people choose to do it in a base log 3 so that the log 3 of 3 is 1 and that disappears. Personally, I prefer to use base 10, so when I don't write a base, it means it is base 10. So now what I'm going to do is I'm going to bring these over to the other side. Log 3 equals 2x log 5 minus x log 3. Now I can factorise. Log 3 equals x bracket, and then I'll be able to divide and I'll have my answer. So that's all of section A. Section B, okay, section B. Let me move this into range. Section B, so question 11. It says figure 11 shows the sketch of the curve with equation y equals x minus 4 over x squared. First part, find dy by dx. Now, when I go to find dy by dx, it's easier for me if I've written that as x to the power of minus 2. So then I can just, when I differentiate this bit, bring the power down, take 1 off the power. So differentiating, I get 1 and then minus 2 times minus 4 is 8, x to the minus 3. I'm going to leave it like that for a second. The next part says show that d2y by dx squared equals something. So we just differentiate again, bring the power down, we get minus 24 x to the power of minus 4, and then I can write that as minus 24 over x to the 4, which is what they asked me to do. Part 2. Hence find the coordinates of the stationary point on the curve and verify that it's a maximum. So for stationary points, I need to make the derivative, the first derivative, equal to 0. So dy by dx needs to equal 0. So in this case, 1 plus 8, and I'm actually going to put this x to the minus 3 back on the bottom. It helps me to solve this particular equation. I'm then going to move one of these two bits to the other side, which might as well move the 1. Okay, make it correct. And then I'm just going to multiply this up and I get that. Okay, it's actually easier now I think about it if the minus is on the other side. Okay, so minus 8 equals x cubed, so that we get that x equals minus 2. It says find the coordinates, so that means I need to find the y value. I'm not going to do that, but you must. So y equals something. Obviously, to get the y value, you put it back into the original equation up here. The equation that's, if you want y, you put it into the equation that says y equals. Okay, and verify that the stationary point is a maximum. Well, so to verify, you take your expression for d2y by dx squared, which is minus 24 over x to the 4, and you plug your x is minus 2 into there, and because you then will get a negative number, it means it's a maximum, and you just must write that conclusion out. Part 3, find the equation of the normal to the curve when x equals minus 1. Well, when x is minus 1, one of the things I'm going to need to know is what the y value is. So I would put that back into the original equation all the way back up here. I'm also going to need to know the gradient. Now, if for x is minus 1, I put minus 1 into this expression, and that will give me the gradient. So then I need to do the negative reciprocal to the gradient of the normal. And from there, I would then use the formula as per usual for a straight line. Y minus y1 equals gradient x minus x1. Okay, so you start with your x's minus 1, you find the y value, you take your x's minus 1, you find the gradient of the tangent, you then find the gradient of the normal, and you put those things in. Okay, next question. Question 12. Oscar is designing a building. It's actually probably easier if I do this on the paper here. Okay, so just about to see this. Use the trapezium rule with 5 strips to estimate the area of the end wall of the building. So I'm just going to draw my strips in so it's clear to me where they are. Now this distance here, from here to here, because this x coordinate here is 15, this must be 15 divided by 5 means strip width is 3. So the area is approximately equal to the strip width, 3, divided by 2. This is just all part of the formula. Then it's this height, which is 9, and this height here, which is 9.1, and then 2 lots of each of these heights, because each of these is in both trapeziums, or in 2 trapeziums. So 2 lots of 10.7 plus 11.7 plus 11.9 plus 11.0. Work it out, put it in your calculator, and that's your answer to the first part, 4 marks. It then says, Oscar now uses this equation, to model the curve of the roof. Calculate the difference between the height of the roof when x equals 12 given by the model and the data as shown. So when x equals 12, if I put 12 into here, I'll get a number for y, and if I look over here at the graph, when x is 12, it tells me 11.0. So I can simply work out the difference between the number I get when I put it into here and the number I've got here, which is 11. Okay. And then it says here, use integration to find the area of the end wall given by this model. So integration, it tells us, but we should have known that anyway. We're integrating between x is 0, check you can see what I'm talking about, x is 0 and 15. So on our integral sign, 0 and 15. And then we've got this expression. Okay, and the examiner wants to see that you understand where to put the numbers, where to put the symbols, where to put the dx. You then integrate, so as per normal, raise the power by 1 and divide by the new power. Now, sometimes on your calculator you can do this without, you just type it in, but if the question nowadays says show reasoning, or complex reasoning or direct reasoning, you'd have to do it by hand like this. So at this point you put 0 and 15. Now, when I've marked this, what some of you haven't made it clear is that you're going to substitute 15 into this expression here. So you put in your 15, I'm not going to do it all, etc, etc. So you substitute the 15 in, and then you have to demonstrate that you're substituting the 0 in. Now the fact that you can see 0, 0, 0, 0 is fine, you don't have to write all of the bits out, but you do need to show me that you have substituted 0 in, and then you use your calculator. Okay, so that brings us to the last question. And just going to go through this a tiny bit slower, I think. So the question's about a glacier. You don't have to read it in great detail, but it's a good idea to get a rough idea of what we're talking about. Okay, time is measured from 1960, so in 1965 it's 5 years on, etc. Okay, an exponential model may be used for these data, assuming that the relationship is of this form. Okay, show that this relationship may be expressed in this form, stating the values of m and c. So you write down what they give us, what they start with, h equals a times 10 to the bt. You should know by the look of the question that it's a log question, so you're going to take logs of both sides. Log h equals log of a times 10 to the bt. Now there is a rule in logs, which is that log of xy equals log x plus log y, and we're going to use that rule to break this down. So this is my x and this is my y, so I'm just going to have log of this plus log of this. So log of h equals log of a, I'll move it in a second. Okay, the whole point of doing that is that I can now bring the power down. A spider. Now hopefully you know that log base 10 of 10 is 1, so that goes. So I've now got log h equals log a plus bt, and if I compare that to what they wanted me to at the start, they wanted log h equals mt plus c. So just to show them that I've got that, I'm going to write it like this. This is log h equals, this is my c, mt, so they can see that the t lines up that and that. So it then tells me to stating the values of m and c. So m equals b and c equals log a. That's what they're after at that point. Okay, the next one says complete the table of values in the answer book, giving your answers correct to 2 decimal places, and plot the graph against t by drawing a line of best fit. So we go over here and we need to work out for each of these points what log of h values are. So log of 0.7 is minus 0.15. I haven't got space. If you've got space, go to 3 decimal places. Okay, log of 1. Did actually know that, log of 1.7, 0.23 log of 2.3 0.36. I'll just do one more. Log of 3.6 0.56. Okay, so obviously you would keep doing all of that, and now we're going to plot points. So across the bottom we've got the t value, can you see that? And then we've got the log value, which is what we're going to be plotting on this axis. So the first point is 5 minus 0.15. You have to be as accurate as you can. I'll just move that a second. The next point is 10, 0. Then we've got 15, 0.23, 0.2, 2223, 20, 0.36, and 25, 0.56. Okay, now it says, when it says draw by eye, a line of best fit, it means use a ruler. It's talking about not having to put the, I forgot what it's called, the mean values in. It's a technicality. I don't have a ruler here, so I'm just going to go as best I can. Okay, so that's part 2 completed. Part 3, use your graph to find h in terms of t for this model. Well, we've got this expression, h equals, where can I write it? A times 10 to the bt. So to find an expression for h, I need to work out the a and work out the b. But we already had, on the previous page, we had written down that m is, the gradient is b, and the intercept is log a. So the intercept, I'm going to go minus 0.28. I'll just do it here, minus 0.28. Okay, let me just check. The intercept equals log a. And the gradient, so for the gradient you just need to draw a right angle triangle. Okay, so b is the gradient. And in this case, that's 0.13 divided by 4. Which is 0.0325. Okay, so I've got my gradient. Now I need to work out what a is. So if I've got log a is this, then what I need to do is what's called the anti-log, the opposite of log, to get that. So, clear my calculator, shift log, and I've got minus 0.28, which equals 0.52. Okay, so when it wants an expression for h, which is this thing, I can go over here and say h equals a 0.52 times by 10 to the power of bt. I haven't got space to write it, but that would go there. Okay. Calculate by how much the glacier will reduce in thickness between 2010 and 2020 according to the model. So 2010, we've got a figure here, okay, but if we use the model, might be better, okay. What we're doing is in putting 50, beg your pardon, over here, putting 50 into here, and then putting 55 into here, no, 50 into here, and then 60 into here, and then doing one subtract the other, and you should be able to work that out. And the last question says, give one reason why this model will not be suitable in the long term. Okay, and what you'll find is that in the long term, it's going to continue to get thinner and thinner. Okay, which is obviously not possible. there will come a limit where it's disappeared, it can't get any thinner. Okay, thank you.